Test, 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 test. Are you guys there?
Yep.
Okay, so I'm gonna try to do some streaming today. So if you wouldn't mind, I'd like to test some things with you since you're early.
Sure.
Now I'm hearing like a feedback echo over here. What is that? Oh wait, never mind. I think I know what it is. Sorry, I'm hearing myself like come back here. Shoot. Let me put the stream in the chat here. Ah, there we go. That's better. All right. Okay, so Joe, is the stream look okay for you? Just see those hands sitting there? I put a link in the chat.
I see the video.
Okay, I'm gonna switch over to the machine that's.
I meant the link to the video. I see.
Oh, okay.
I don't see anything shared.
The link to the video?
Yeah, in the chat, I just see the YouTube link.
Yeah, right. That's it.
Oh, okay. Yeah.
That's a live stream actually. So what I want to test is to make sure that when I go to the machine that's live streaming VR, I want to make sure that you can hear me when I go over there. So I'm going to switch over to that.
Right one thing I need to mention is like those of us who use like the headsets, it uses a different type of audio a lot of time. Like this one's not a gaming headset; it's a music headset, so it will use like the cell phone mode or whatever. So anything, if I play a video or anything, I can't hear the video while I'm using it for Zoom. Now I might be able to switch my. Actually, I can probably switch it to my speakers, but other people might have that issue. Let me see.
You should be able to hear some like ambient sound in the video.
Yeah. Okay. Yeah, I can hear it through my speakers. I just can't hear it through these while I'm listening to chat through these. But yeah, I can. Diegetic UI, is that the video?
No, that was not the. Did I send the wrong link in there?
Yeah.
Yeah, ignore that. Stream link.
Was body gaming headset too. That would have fixed the issue because gaming headsets often have where you can have both chat and like PC sounds at the same time coming through. I just don't know where mine are right now.
Okay. Let me. Did you try that second link?
Let me see. Okay, it's loading. Okay, yeah, I see the hands now.
Okay. I'm going to switch to that machine and see if make sure the microphone's working.
Okay. Okay. Yep. Okay. Yeah, I could. So I could hear myself talking to you, and then I could hear myself coming through my speakers going back into the mic again. So it was like an echo of myself, and I got quieter and quieter.
More minutes.
Oh, there we go. Yeah, I definitely hear everything I say coming back through the YouTube video.
It would be if it were non. In the mid-2000s, when the PS3 and Xbox 360 generation was on the horizon, powerful game hardware allowed for incredible new graphic fidelity. And for a time, games were obsessed with total immersion. But one particular aspect of games stood in the way of that immersion: on-screen UI. Because it's not very realistic to constantly see floating boxes and bars after all. So, a lot of games attempted to suspend the player's disbelief by adopting UI that was part of the game narrative itself. So, were the results worth the effort? This episode is brought to you by CuriosityStream, the world's first streaming service dedicated to the lifelong quest to learn, explore, and understand. Check it out for yourself at curiositystream.com/extra credits for a free month. Real quick up top, please welcome back Elisa Bishop, doing guest art for this episode, and who also, as luck would have it, is an actual UI designer by trade. Thanks, Elisa. In media, there's this term diegetic, which means part of the world. You may be familiar with it in terms of sound. A non-diegetic sound is when that sound is detached from the fictional world. A typical example of this is, say, background music in a movie. Ah, like that. But if one of the characters on screen is holding, say, a boombox, and the music is coming out of that, then the music becomes diegetic, because it's now part of the world. One isn't strictly better than the other, it's just an artistic choice. Video games, though, have a unique element: the UI and HUD. And when you think about it, on-screen UI is probably one of the most artificial elements of a game. Because no matter how realistic hair animation or fish AI gets, you'll always be able to tell a game screenshot from real life if you're seeing health bars and ammo counts in the corner. And you know what's funny? Watch some of those E3 gameplay trailers and see how they remove all the UI elements to make it look more cinematic and less gamey. So let's break down how game UI can be built. As this excellent chart from Eric Fagerholt and Magnus Lorentzen shows, there are 4 ways we can do game UI. Diegetic, such as Halo 3's ammo displays mounted on the guns, and non-diegetic, having the ammo count flat on the edge of the screen. But games also have a weird hybrid: spatial elements. If something is spatial UI, it exists physically in the game world, but only to the player. So as far as the characters are concerned, it's not there. Which is a contrast with diegetic UI, because that's viewable to both the players and the characters. Spatial UI is often seen in glowing boxes that point where to go, or exclamation points that point to points of interest. Pointy. We can reasonably guess that there really isn't a giant box hovering over a wall saying, press X to hide behind walls for cover, or that someone just stands around in town all day with a bright yellow punctuation mark dangling over their head. But spatial UI is useful, because sometimes information is better presented in context, such as the box showing you how to crouch behind that wall, actually being next to the wall, rather than always popping up centered on the screen, no matter where you're looking. The final UI type, meta, is pretty interesting, because it makes a distinction between the game space and the screen space. In games with non-diegetic UI, the screen and the HUD are not part of the game world, and characters aren't aware that they even exist. For instance, there really isn't a camera following Link around Hyrule displaying a bar of hearts to represent his life. It's there for the sake of the player. But meta UI straddles this distinction. A meta element, in effect, is part of the game world, but doesn't spatially exist in that world. The most common example of this is blood splatter on the screen that many shooter games use to indicate damage. Unlike Link's hearts, we can assume blood leaving bodies does exist in the world we're playing in, but the actual splatter on the camera is just a meta-visual effect that informs the player they've been hit. So now that we've broken that down, let's get back to the aforementioned boom period of diegetic UI. Because a lot of interesting experiments were made for the sake of game realism, and an entire slew of games tried to rationalize as much UI as possible through diegetic, spatial, or meta elements. For instance, Dead Space had health tubes on the character's suits. Far Cry 2 showed your character holding a real map and compass, and Alone in the Dark 2 had its infamous jacket inventory system. Another approach was the first Assassin's Creed, which kept non-diegetic UI, but bent over backwards to explain everything through narrative context. So what did we learn from that time period? Well, unfortunately, what most of those games found was that the result wasn't really worth the effort. At least not most of the time. Some experiments turned out well, others not so much. And this is apparent when we see how many games today largely stick to 2D HUDs. Some information, it seems, is just better represented by a bar or number on screen, or even a menu list. This is because the purpose of UI is to show critical information to the player. So displaying that information in the most straightforward way is generally better. Now sure, long fancy animations like opening up your jacket to view your inventory may be clever narrative hand waves, but they get old real fast. Of course, this isn't to say that diegetic UI can't be interesting or immersive if done well, but good UI should be legible first and stylized second. You know, form after function. If you really think diegetic UI is a good fit for your game, then you have to make sure that the information is no less convenient to access than it would be if it were non-diegetic. For instance, Dead Space's diegetic health worked because the over-the-shoulder camera meant that the health bar was always visible on screen, as it would have been in 2D. But on the flip side, Dead Space's diegetic 3D map screen was so janky and unusable, most players just gave up on it entirely. And sometimes, diegetic UI can fight against the way UI elements have been codified over the years. For instance, is health on the bottom left, ammo on the bottom right really the best placement for this information? Maybe, or maybe not. But we're all so used to it by now that trying to radically change it in your game will probably just annoy people, no matter how cleverly you've integrated it with the narrative. So it's important to stop and ask yourself, how is our diegetic UI elements benefiting the game without being less convenient? Now, all that said, we don't want to sound too negative on the idea of diegetic UI, because it's great when games pay so much attention to detail that even their UI is part of the game's story. I mean, many of us play games.
Well, I'll stop that right there. Key distinction in this video is really showcasing is, diegetic and non-diegetic UI. And it's timely for our current discussion because VR maybe slants the perception of this a little bit, right? When you're playing on a monitor and a 2D screen, then oftentimes it makes sense to overlay 2D elements, right? Those might be, in many cases, the best way of communicating two-dimensional information. And, that has, the different design merits, kind of what the video talked about. But when you're in VR, it's very different, mostly because of the spatial awareness. On a 2D screen, it is essentially flat, and you're kind of seeing a projected kind of 3D thing there. But when you're in VR, you really do have a very solid sense of space. And generally, diegetic UI, I think, really comes into its own on this. And we're going to see some examples today. We're going to go through the highest budget VR title that exists, and I'll go through it, kind of critique some things and show you kind of what the state of the art is, and kind of just think about things design-wise. But before we get to that, I want to take a little aside to talk about the rendering of VR a little bit. So let's come in here. All right. Let's go from here. All right. So, I think it's useful if you're trying to understand things that are being rendered in 3D and why they do what they do, to know kind of the steps of not just the graphics pipeline, but kind of the order that you have to do things to get the image on the screen correctly and efficiently, right? So if we look at this image right here, the first thing you're going to do is you're going to say, all right, what are the only objects I can see, so I can make sure I don't waste any time passing that through the pipeline. All right, so we get rid of those. And as you remember with shadows, right, we have to render everything from the light's point of view. Great. And then finally we can do normal rendering of all the opaque objects. And we do that because we can take advantage of the depth buffer. The skybox comes afterward because you don't really want to waste time drawing the skybox if you can't see it anyway. So this is kind of it's generally better to do that afterward. And then you can apply some sort of image effects for the opaque stuff. You can render the transparent stuff using the painter's algorithm like we talked about, and then apply more effects and get that out of there. But part of the issue is you got to do this for both eyes, and kind of want to show you, how Unity started taking this apart, besides the whole idea of single pass versus multi-pass. So in order for them to get to that whole single pass stuff, there were some things along the way that kind of helped them get there. And if you look at each eye, right, you start off with pretty much just doing all the work twice. That's not great. But you can notice that, you really don't have to cull things or render the shadows for every single eye. And the shadows are from the perspective of the light, so that's independent. And then cull.
Are you sharing a screen?
Oh, yeah. Can you not see it? My bad. Sorry. Let's start this. Share screen. Turn record on.
This meeting is being recorded.
Getting some stuff here. Is my window at? Here we go. All right. So let's see here. Yeah, this is much more useful to have a picture, right? So you can see all the steps here, right? There is the pipeline you're going to go through, but you're going to cull, do shadows from light's point of view, opaque, skybox, transparents. Then we can see that you're pretty much just paying double the cost for an eye that's only a little bit different. So the first strategy here would be to just make sure you don't do things twice that don't actually have to be done twice, right? That you can share between them. And so you can pull this out into just a single pass where we cull, we do shadows. But culling happened from the view frustum. If you remember, each eye is actually going to have a slightly different view frustum. So instead, what you could do is you could just make one big view frustum that kind of encompasses both of them, and then that's going to be a lot more efficient to just go based on that. So that's kind of what the first version of this they did was. So better multi-pass, make sure not to duplicate things that don't need to be done. But of course, single pass is what we're going for here. And what they did is being able to do left and right eyes both at the same time. So that was kind of the stuff we talked about last time with the single pass. And when you're doing that, ideally you can just check the little drop down and say, hey, yeah, Unity, do single pass. And if everything looks just same as it was before, then you probably want to leave it at that. If things are rendering badly, of course, and go back to the multi-pass we saw before. And here's some metrics you can see between the two. So yeah, I guess one good takeaway from this is to keep in mind that rendering is not just something that happens on the graphics card exactly. I mean, yeah, the whole pipeline is executed there, but it's a coordinated effort between the CPU and the GPU. So whenever you're drawing things, right, you're going to make those draw calls that starts its life on the CPU, and then it goes off to the driver, and the driver does different complicated things to make sure it can get it ready for the GPU. So there's kind of a lot of overhead to render things that actually comes on the CPU. So if you don't have to do all this stuff on the CPU and you're not thrashing memory, going through your list twice, right? We can see the CPU jumps quite a bit further down. And the GPU savings are actually not that substantial, just because video cards at this point are pretty well optimized for doing a lot of these tasks. So it's a little bit surprising that it's only that much, but you do see some savings. And then taking this a little bit further, you can actually do this instancing thing, which you don't have to worry about. It's a drop down, and that reduces the CPU load a little bit further. But that said, let's go back to the whole idea of design, really, and when it comes to VR. There's a couple of different vectors we can look at here, and I don't mean geometric vectors. I mean, we could kind of go along the design of the UI, right? Just thinking about how we communicate to the player, like what's a really good way to make things very clear and direct, and make sure that the player can be immersed into whatever it is that they're actually trying to do. And so there's a design aspect of that, and then kind of intertwined with that is the idea of designing for comfort, right? If someone's sick, then obviously that's going to interfere with their ability to focus on your experience as well. So looking at these different things, let's kind of go through the list here, some recommendations. And after we go through this list, we're gonna go through this game called Half-Life Alyx, and look at a few things and see how they handle this stuff, because it's pretty much the poster child of like just doing everything right for the most part. So first things first, when you're allowing your player to move around in a scene, ideally they'd be able to move themselves. And in a perfectly ideal world, you'd have a big warehouse like in The Void that we saw that demo for. What do they show in The Void? They showed like Ghostbusters or whatever, but they're walking around a big warehouse and nothing's moving them, right? They're moving themselves. So there's this one-to-one correspondence between what they see and how they're actually commanding their body to move. But it's not really realistic to have a big warehouse to do that sort of thing and the budget to pull it off. So for practical purposes, you have to find a way to be able to move yourself around the scene. We saw teleport as well, but you could imagine just using like a joystick or whatever to move the player forward and to the side. And that's where you start to have a disconnect between how you're moving your body and the visual feedback you get on the screen, right? And different people have varying tolerances to that sort of thing, but if you can help it, you really don't want to force a user to move that way. And I think this sums it up pretty well. When there's a conflict between the user's motion and the visually perceived motion, results in a visual vestibular sensory mismatch, right? So besides nausea, right, there's eye strain is not good, and just general disorientation. So it's generally good to either just go with the teleport kind of mechanic, that you refine, or give the player an option to choose different things, because some players won't mind moving themselves around and having that kind of control, but most people probably will. Another way to minimize that is to, when you do have to move the player, is to give them a foreground element so that doesn't move, right? So if you're like inside of a car, you can see the dashboard and the frame of the car kind of going around you, and that kind of anchors you to accept, I think, the things that are moving that you see through the windshield. So that's better. It still may not be comfortable for a lot of people. And the one that probably is the biggest offender is when it comes to rotation. If you rotate the player's head, that even less people tolerate that well. You can probably translate someone around, and it's not too bad, but rotating them is definitely worse. And at this point, though, there's a little bit of a trade-off to be made, and that's because usually we're tethered, and when you're going around inside of a virtual world and you're teleporting, you want to look behind yourself, look to the side, and you end up twisting, and I end up turning myself into a cord mummy because I just get tangled and wrapped around in that thing. So that can be pretty inconvenient. So what you want to do is give the player a way to kind of rotate, but in a more teleport kind of fashion, where they could just tap the stick and it just kind of snaps them in incremental degrees. And we'll see that in Half-Life Alyx. Once I got used to that in that game, it was kind of like I was very disappointed when I didn't have that feature on other games or experiences. Another issue, and this one's I think a pretty big immersion breaker, and that's the fact that you have objects that are around you, spatially located, and there's nothing necessarily stopping you from sticking your head through an object, right? You can do that, and what do you normally get? You got near plane clipping, and then you can see on the inside of stuff, and that's very immersion breaking. And we'll see another good example in Half-Life Alyx how they deal with this. It's pretty interesting and works amazingly well. Maintain a high frame rate, and then world space UI. Generally, when you're thinking of VR or AR, any of the Rs, really the new abilities that really brings to the forefront is largely spatially based, right? So when you're really situated in a space and you could take advantage of all the degrees of freedom that normal 3D space has, like in the real world, it feels more natural and easier to actually use something like a diegetic UI, where your UI is part of the world, right? You don't want to just paste a PDF like flat on the screen in front of someone. That's actually a horrible experience, but it also tends to be the thing that new developers automatically do. And why shouldn't they, right? We have this long history in 2D, and so what do people think? They think, oh, well, things work great in one medium, so naturally I can just take that thing and bring it into a new medium. And it turns out the strengths and weaknesses of both aren't really not the same, and you end up having not only not a good experience, but a rather poor one that would sour someone on the good things that VR brings to the table. So let's see. All that said, do you guys have any questions about this, or what we got here? Got 30 minutes. Okay, so what I'm going to do next is I'm going to switch computers over to another machine where I am streaming on YouTube. And one of the main reasons I'm doing that is because the aspect ratio of the screen can be really poor if I just try to stream it from the screen. It'll look like I'm zoomed in everything, and you won't see very well. So by going to the stream, I have a special plugin that kind of remaps it to see it a little bit better. So I want you guys to go into the chat. It's the stream link, that second link in there. I'll repaste it in here. It's not showing there. Right. So let me make sure that's still running. Looks like it's okay. All right. I'm going to move over there and we'll do a quick audio check and then get this thing going. Stop this.
Yes.
Talking. No, we can't.
Alex! How's it looking up there?
It's good, Dad. Metrocop movement is normal. Same for the Combine patrols. How's it going in the stockyard?
One Combine mini reactor from a shipment of 4,000. They're never going to miss it. Here, see for yourself.
And not only that, someone's hacked into the Combine construction network.
Don't get greedy, guys. We're not made of time here.
1 minute and I'm out, guaranteed.
Oh, also, I spotted the Combine moving supplies into the quarantine zone. That place has been deserted for years.
That is odd. Well, we'll look into it when we get back.
What is this?
Meet back at the safe house, baby. We'll be there soon.
It looks like...
What is it, Russell?
Would you... Terrific.
I need to make this game a non-VR for the rest of us. I need to make this in a non-VR version.
Alex! Alex, the signal's back. Can you hear me? Are you okay?
Russell, I'm good. How's Dad?
They've got him on the train. He's on the move. You've got to find Fairview Junction before they get there.
I'm working on it.
So anything happened when you cut out?
You're not gonna believe this, but I ran into a Vortigaunt.
A Vortigaunt? What was he doing down there?
Hiding. I think he escaped from the Combine.
What did he say?
You ever meet a Vortigaunt? He said crazy Vortigaunt stuff. Hey, Russell. I just found a loose syringe of God knows what. Is this medicine?
Does it have a skull and crossbones on it?
I don't see one.
Probably medicine then.
Oh, that Vortigaunt I met? He did give me a head crab to eat.
Oh, right! What did it taste like? Tell me how you...
Russell! I didn't eat it.
Right. Of course you didn't. No, that's the right decision.
Oh, that zombie has a shotgun. I'd never survive a jump from this height.
No, absolutely not. Why? Were you considering it?
Whoa!
Do you hear that?
Yeah. Let's get this shotgun and get out of here. Run.
I guess this this recording will not be too fun to watch since it's not showing that stream. So that's most of what I had planned to show you guys. I guess we don't really have too much extra time here. There is one last thing actually. So I spent some time looking into the whole possibility space of different routes you could go when you're trying to get started doing VR stuff with Unity. And like if you're using the Valve Index or HTC Vive, you can go Steam VR. You currently can't use this one. If you're using the Oculus Rift or the Quest, you could use the built-in Oculus stuff, or you could use the interaction toolkit. They're kind of different, and this one's starting to mature a little bit, but it's it's a little bit bare bones, I think, right now as is. And VRTK used to be promising in the past, and that can work across the board. It's just it can be a little cumbersome to work with. You know, it's like just seems overly complicated. But VRTK handles all headsets, and ideally, you know, you wouldn't have to worry about writing code specific to any one of these. You'd just be able to use, you know, the one to rule them all, and you kind of can right now. They're going to have support for the Vive and the Index soonish, I think, but I don't think it's not quite there at this point. If you guys are starting doing thesis work in Unity in, I don't know, 3, 4, 6 months, you know, this might all change quite a bit. So you can take that with a grain of salt. However, I would recommend that if you do want to start looking in Unity's version, the quick and easy way to do that is to actually do it straight through the Unity Hub. If you come over here to the Learn tab, you'll actually see, you know, projects and tutorials. And there's a VR beginner escape room in here that's actually pretty good. So I would start there and take a look at that. Let's see, I think I actually have this open right here. So these are very large gizmos, icons, okay. And yeah, this kind of showcases different features that they have in here. And this is definitely worth downloading and checking out and seeing what they do. Yeah, that's about all I got for VR. I guess the last thing is kind of just seeing what you guys want to focus on next. You know, I'm kind of a big part of what I'm doing for you in this class, just going wherever it is you guys want to go. So I can go based on those poll results and try to make something, but I think it would work better if you know, let me know whatever it is that you're having trouble with or you're interested in, and maybe we could focus on that. So you guys have any questions?
Have you tested out the Pimax yet?
Shoot, I wasn't sharing my screen yet, or again, right? I've never tried the Pimax. No, I don't think we have one in-house. Where did you get to use it?
There is a one of my former coworkers was in the area. He had the 5K plus. It's a 120 hertz version of it. And I liked it, but it has this, you can see obvious like distortion on the left and right of your periphery. Like I'm not sure it's something you'd get used to, but the enhanced field of view is definitely good in games that support it. But I'm trying to debate between that and the Valve Index because the Rift S field of view is just not cutting it anymore for me.
Well, the index is pretty good. Definitely worth checking out. I'm not sure if we have one on order or not, but you know, it's hard to know what's going on now that we're all working from home. Let's see. Oh yeah. So now that I'm sharing my screen, yeah, you can see here's the Unity Hub. Here's the Learn section, projects. There's the VR escape room right here. And then if I look at the open project, you know, you can see here's the inside of a scene right now. It's it's a nice little demo to check out. And you can kind of reverse and see how they do certain things. There's also this prototype scene where you can kind of just see how the objects are set up to be interactable. And so we're done with this one. Let me check the poll again here. Okay, so you got general scripting, game engines. Yeah, maybe we can do a little bit of both. So there won't be any class tomorrow, but we'll pick up on Wednesday, and I'll probably pick out some little tips and tricks of code, and we'll do start a little bit of a run through game engines in general. There's kind of a lot of history and some interesting aspects, and as we progress from one generation to the next, we've gone through many generations already, and with each generation, there's kind of a prevalent or a common set of features that you kind of expect to see in game engines for that generation, and we'll kind of look at how those things evolved and how we got to where we are now, and where things are going, which is pretty interesting. So I think maybe we'll do this over a couple sessions, and we'll see you guys on Wednesday. And we'll stick around if you guys have any questions. Where is my, oh.
The recording has stopped.
Hey, Michael.
Bill?
So there was one thing that I did this weekend that I thought I would mention to you. I don't know if you've heard of it. I'm sure you have, but maybe you could. This is something you could discuss in class. I think it's called display.land. Have you ever heard of it?
Display.land? No. What is that?
So it's an app, and you can also go online. But
oh, HDMI over LAN. So instead of streaming, I could have just.
No,
Oh.
Not that at all. So what you can do is you take your phone and you can literally scan things and walk around, and it's almost like you're taking a video, and it plots little geographic circles in your phone, and then you can turn it into a 3D poly mesh.
Yeah.
And download into Unity. I didn't know if you wanted to discuss that in class or not. I think it's cool. I couldn't get it to do very well on my phone because I went to NPS. I tried to do the classroom, and it was too big. But I was able to do my son on the couch without any problems at all.
Oh, really? You must have got him to hold real still.
Yeah.
Yeah, that's cool. I'll check that one out.
Okay.
Yeah, the basic technique that is being used to do that, and there's lots of different people that do similar things. It's called photogrammetry. So it's able to like take real world measurements through photos, right? It gets these overlapping images, and it can reconstruct the environment. Yeah, that's actually a pretty big deal going forward, and I'm sure I'll touch on that in like kind of toward the end of the game engine stuff as well.
Yeah, just another topic to cover, but if you want, I can send you the link to it.
Sure, yeah.
Okay. All right. Sounds good.
Cool. All right. Thanks, Bill.
Talk to you later.